Hello and welcome to the Unit 0, Section 1 video on the real number system. What we're going to talk about in this video is a little bit about how numbers are classified. Okay, we've got several different types of sets of numbers, and we're going to talk about how we can describe numbers. So we're going to start off with natural numbers. The natural numbers are all of your positive numbers. Okay, and when we say positive numbers, we're talking about your counting numbers. 1, 2, 3, 4, and so on from there, okay? Now, whole numbers are including your natural numbers, so they're all your natural numbers, plus we throw in the number 0 along with it, okay? So we have everything that's above in the natural numbers plus 0. So 1, 2, 3, 4, and 0 included. Now, talking about integers, we're expanding to an even bigger set, okay? An integer is the positive and negative whole numbers. Okay, so now we're including everything that's positive and negative, which means we have all negative numbers leading up to -3, -2, -1. We're still including 0. We're still including 1, 2, and 3, and all the positive numbers that go beyond that. So basically, every number that is not a fraction is an integer. Also, every number that is not a decimal is an integer. So now let's talk about what a rational number is. A rational number is a number that can be written as a fraction. If you think about the word rational, what is another way that we can call a fraction? Let's see if I can write it correctly. F-R-A-C-T-I-O-N, fraction. All numbers that can be written as a fraction. A fraction can also be called a ratio. That's where we get the word rational, because a fraction is a ratio, so fractions are rational numbers. This includes decimals that terminate. You can also say end, and numbers or decimals that repeat. Okay, so some examples of this would be the number 1/2, which can also be written as 0.5, the number 1/3, which can be written as 0.333 repeating, which we usually denote with a line over it to show that that's repeating. Another example would be 0.27956 Okay, just an example here, okay? Those are all rational numbers. That last fraction that last decimal I just wrote is a rational number because this can be written as a fraction. This can be written as 279,564 over a million. Okay, we can write it as a fraction, so therefore it is a rational number. An irrational number includes numbers that cannot be written as a fraction. These are decimals that don't terminate. Okay, and again, the word you could use here is end if you want to use a different word. So they do not terminate or repeat. Easy examples include most square roots. The only square roots it does not include are the square root of perfect squares. So for example, square root of 4 is 2, so therefore that's a rational number or an integer, because the square root of 4, it comes out to a nice round number. Square root of 2, however, if you were to put that in your calculator, you'll find it's a decimal that does not repeat, and it just goes on and on. Even though the calculator cuts it off at some point, it does continue on. It only can go so far in a calculator, okay? The other example of this is pi. Pi is an example. 3.1415, and it continues on from there. So those are irrational numbers. Numbers that are decimals that go on forever. And then real numbers include everything that we've talked about here. It includes all the rational numbers and all the irrational numbers. So everything that we have said as an example for all these different types, those are all real numbers. You'll get to learn a little bit more about numbers that are imaginary later on in Algebra 2. But for now, in this class, we're going to be talking pretty much about real numbers. All right, so let's classify these real numbers. This is a set diagram, and we are going to separate everything out. So everything in this box is a real number, okay? Real numbers can be separated into irrational numbers and rational numbers. Now, if you notice, every integer is a rational number because every nice round number can be written as a fraction. An easy example of that is the number 2 can be written as 2 over 1. So therefore, integers are included as rational numbers. All integers are rational numbers. Now you notice that whole numbers are 0, 1, 2, 3, 4, 5, 6. Those are all included as integers. So every whole number is an integer. And then finally, natural numbers are all whole numbers. So the only whole number that is not a natural number is 0. All right, let's head on over to some examples and identify all the sets to which each of these belong. So the number 12, we know it's a real number. So next thing we ask, is it rational or irrational? Well, it's not a decimal that goes on forever, so it is rational. Now that we know it's rational, is it an integer? Well, yes, it is an integer. Is it a whole number? Yes, it is. It's positive, and because it is a positive whole number, it is natural. All right, for -5, we know that it's real. We know that it's rational. And it is an integer, but because it is negative, we know that it is not a whole number, and since it's not a whole number, we know it's not a natural number. So you just kind of work your way down that list, okay? Here we have a decimal that repeats, 0.3 repeated forever. So we know it's a real number, and decimals that repeat are rational because it can be expressed as a fraction. This is 1/3. But it is not an integer, so that's as far as we have to go. The number 0 is real. The number 0 is rational. Can 0 be expressed as a fraction? Yes. 0 over anything is 0, so therefore it is rational. It is an integer, and it is a whole number. But because it's 0, it's not a positive number, because 0 is neither positive or negative, it cannot be called a natural number. All right, number 5 here, we have 2.449489, and it goes on, and it doesn't look like it repeats. So therefore, it's real, and it is irrational, because it's a decimal that goes on forever, and it doesn't repeat. Square root of 4. Be careful with this one. What is the square root of 4? The square root of 4 equals 2. So we're really asking, what is 2? Well, 2 is real. 2 is rational. 2 is an integer. It's also a whole number, and it's natural because it's a positive whole number. 5/3. It's real. It's a fraction, so therefore it's rational. But it is not an integer because 5 divided by 3 does not come out nice and even. And finally, pi is real. but it goes on forever as a decimal, so it's irrational. Okay, let's talk about properties of rational and irrational numbers. Rational numbers, when any two rational numbers are multiplied or added, multiplied or added, the answer will always be rational. Now, if we have rational and irrational numbers, the product is always irrational, except for when you multiply by 0. Because when you multiply something by 0, you get 0, and therefore it's rational. The sum can be rational or irrational. It depends on the situation. So you have to take that case by case. So let's take a look at some examples. Let's determine whether each sum, the difference or product, is a rational or irrational number. Okay? Well, for number 1, we have a fraction minus a fraction. Rational minus irrational gives us a rational. That's that first rule that we just wrote down. Here we have an irrational times a rational, rational being 5, irrational is the square root of 12. This is going to end up being irrational because we're not multiplying by 0. 22 plus 0.02 is just 22.02. That's a decimal that terminates, so therefore it's rational. And remember, rational plus irrational is going to give you a rational anyway. Here we have an irrational minus a rational. If we subtract 2, what happens behind the decimal doesn't change. So therefore, this is just irrational. For number 5, we have an irrational because the square root of 26 does not come out nice and even. And then we have it multiplied by a rational number. Well, we're still going to have all that mess going on behind the decimal, so therefore we have irrational. For this one, let's think about this one for a second. We have the square root of 144. That one you should know is 12. Now the square root of 289 may be a little less obvious. If we take the square root of 289 and you put that into your calculator, then what you end up getting is 17. Okay, so this is a rational and a rational. Okay, rational times a rational is going to give you a rational. All right, square root of 2 minus the square root of 2. This is an irrational minus an irrational, but anything subtracted from itself gives you 0, and 0 we know is rational. All right, this is a decimal, but it's rational. This is a fraction. It's rational. Rational times a rational gives us a rational. And then finally, pi plus 5. If we have 3.1415 and so on repeating, and we add 5 to it, then we just end up with 8.1415 and so on repeating. So therefore, we still have an irrational in this case. Okay, so this is where we stopped in class. This is really the end of the notes. But what I'm going to do is go ahead and go over the next page that is in your note packet. These are the ones I left you to do on your own if you needed the extra practice. I'm going to go over those so that you get the additional practice. Okay? So here are a few more additional practice problems. Square root of 10. Let's find out what this belongs to. So the square root of 10, it's real. Square root of 10 is real. And since the square root of 10 does not come out to a nice round number, it is also irrational. All right, for number 2, this number is real and it is rational because it's a nice round number. We know that it is also an integer, but because it's negative, it's not a whole number and it's not a natural number. The number 2 is real, it's rational, it's an integer, it's a whole number, and it's natural. Any positive number is going to satisfy all 5 of those. 4/13 is real and it's rational, but it's not a nice round number, so therefore that's as far as we can go with it. Negative square root of 36. We know that's negative 6 when we do it, so that's real, it's rational, and it's an integer. But because it's negative, it's not a whole number and it's not natural. Square root of 81 is 9. So we know 9 being a positive number is going to satisfy all 4 or all 5 of these. So it's real, it's rational, it's an integer, it's a whole number, and it's natural. The number 0 is real, it's rational, it's an integer, and it's a whole number, but because it's not positive, it's not natural. 13/6 is real, it's rational, but because it doesn't divide evenly, that's as far as we can say. 3 satisfies all 5 because it is a positive number. So it's real, it's rational, it's an integer, it's whole, and it's natural. Square root of 82 does not come out even because we know that the square root of 81 is 9. So therefore, we have a decimal that's repeating, so it's real and it's irrational. Pi, as we've already discussed, is real and irrational because it's a decimal that goes on forever. And then negative 16/8. 16 divided by 8 is 2, so we've got negative 2. So it's real, it's rational, and it's an integer. All right, let's do these last 6 additional practice problems. So here we have a rational plus an irrational. So that means we have an irrational. Because whenever we add a rational number to an irrational number, that decimal is always going to go on forever when you add anything that's rational to it. Here we have a rational times a rational, so this is rational. Here we have a rational plus a rational, so again, rational. This is an irrational minus an irrational, so this is going to be also irrational because the decimals on these two are not the same. Rational plus a rational gives us a rational. And we know this is 12. And we know this is 25. So a rational times a rational gives us a rational. All right, that does it for this section of Unit 0. This was kind of our introduction to number systems. In the next section, Section 2, we will be talking about simplifying expressions.